Ever been watching, a gorgeous 4K movie online and suddenly it just turns into pixel soup? Or it freezes. It happens all the time. It's that constant battle, isn't it? How do you get amazing picture quality without these huge files that just choke your internet connection?
Well, today we're doing a deep dive into some really revolutionary ways people are tackling video encoding. Our sources point towards a company, Wavelet Beam, and some tools they're using IRIS and IRIS.Analyst that seem to be changing the game.
That's right.
Traditional encoding, it's often a bit blunt. You apply one setting to the whole video, and that means trade-offs, always. Quality versus size versus speed. But what's really exciting, the sort of aha moment here, is this idea of encoding that actually understands the video content itself. It adapts.
Okay, let's unpack that. So, Wavelet Beam, according to our sources, uses this IRIS.Analyst tool for shot-based video analysis, and then they use that information, that metadata, to do per-shot encoding with FFmpeg, which is a well-known open-source tool. For someone dealing with video, maybe you're a creator or running up a platform, what's the immediate win there? What does that actually do for you?
Well, think about it. Instead of treating, say, a whole movie as just one big block of data, IRIS.Analyst is smart. It automatically figures out where the scenes change. A quiet landscape shot is very different from a fast car chase. So two big advantages pop out immediately. First, you optimize the bitrate for each scene. So maybe a dark still scene doesn't need many bits. You save them there. But then for that complex action sequence, you use all the bits you save to make it look sharp. Maximum impact.
Right.
And second, it speeds things up a lot because you can process these different shots, these chunks, in parallel. And what's really efficient is that the video denoising, cleaning up the picture, and the analysis, they happen in one step. It streamlines the whole thing.
Wow, okay. That sounds much more efficient. The sources actually call the result a highly optimized, scalable encoding pipeline that delivers excellent video quality with minimal computational overhead.
Can you maybe walk us through that pipeline? How does it actually work, step by step, to get that result?
Sure. It's like, well, a smart assembly line for video. You start with your input video, the original file. That goes into IRIS, working together with IRIS.Analyst. And this is the crucial bit. It's not just finding the shots, it's also cleaning up the video, denoising it, and creating that vital metadata for each shot and breaking it into chunks. Then these prepared chunks head over to the per-shot encoding stage. That's where FFmpeg uses the metadata to compress each scene just right. Finally, there's a reconstruction and muxing step, basically putting all those individually optimized pieces back together smoothly into the final video output. It's adaptive, it's intelligent, way beyond just crushing the file size down. Right, it's targeted compression. So what does this mean for, the person actually watching, for the end user? The sources bring up this ultra-low bitrate encoding capability that sounds, well, almost too good to be true. How does that affect what we see?
Yeah, it's potentially a game changer, especially for getting video to more people.
Yeah.
Because the bitrate adapts scene by scene. You can go to lower bitrates, which usually means less detail, but because it's done intelligently per shot, the transitions to maybe lower resolutions can feel much smoother, less jarring. The sources mention this really interesting technical feat, encoding UHD video, that's 4K, at nearly 60 frames per second using HEVC at just 2.7 megabits per second. Now, okay, that's pushing the limits. It shows what the tech can do, maybe not what you'd offer everyone, always. But think about screaming high-quality video in places with bad internet or over mobile networks. It really opens things up, new audiences, new possibilities.
So the big picture here, the main takeaway, seems to be that this smarter adaptive encoding is a win-win. Better quality, more efficiency. Getting more, using less, essentially. Less data, less processing power needed compared to brute force methods.
Exactly. And you start thinking, how could this change things? Streaming platforms, sure. But what about movie making? Digital archives. It really could reshape how we deliver high-quality digital experiences. Makes you wonder what else is possible. And, companies like Wavelet Beam, they're the ones pushing these boundaries, showing what's next for video.
Absolutely. And if you're someone who works with video or you're just fascinated by this tech, seeing these kinds of advancements firsthand is pretty valuable. It might be worth looking out for companies like Wavelet Beam at big industry events, something like, say, IBC 2025, to really see where things are headed.